Hi everybody, my name is Paolo Dragone, I'm from University of Trento, and today I'm going to talk about our application of constructive recommendation to telco service bundling. Nowadays, telco companies use bundling for selling their products, but what they do, they usually make pre-made deals, a bunch of pre-made deals with little to no room for personalization. Despite the fact that personalization is actually has been shown to be good for user satisfaction and acquisition and retention. So we go in the opposite direction, and we want to build a recommendation system that allows the user to choose a plan among all the possible combinations of the components of a plan. But doing that is quite tricky. There are some challenges. First and foremost, the space of possible choices of possible plans is combinatorial and is exponentially large in the number of components. And so exploring this space is actually very difficult. Also, we are dealing with non-expert users, so they do not a priori know what their preferences are, and they do not know what to expect from the systems. So we kind of need to learn their preferences through interacting with them. Also, we have several feasibility constraints that we need to take into account because there can be some incompatibilities between the components. For instance, you cannot have, a smartphone if you don't have a mobile data plan. Also, to make things very complicated, we don't have a lot of data in these domains because telco companies are really secretive about it. So we need to start basically from scratch. And the solution we adopt for this dealing with these challenges is called constructive recommendation. So I don't have a lot of time to go into the details, technical details of our framework, but in a nutshell, and I'm a bit oversimplifying here, constructive recommendation is a combination of coactive learning and combinatorial optimization. So coactive learning is a technique that's able to learn user preferences from improvements over recommended objects. For instance, if we recommend a plan, the user is able to make some changes, and given this feedback, the algorithm is able to learn the user preferences and make better recommendation afterwards. And of course, we need combinatorial optimization to generate new plans that satisfy both the preferences of the user and the constraints of the problem. So this is the system we developed. We developed this system as a web application. This is the interface. We call it Smart Plan. And at any given iteration, the user sees a plan with all the components. And the user is able to go back and forth over the recommended plans. And then a given iteration, the user is able either to choose that plan as their final one, if they're satisfied with it, or exit without choosing any plan, or suggest some changes. And when they're suggesting changes, basically the user is able to give feedback to the system in terms of I want more of some component, I want less of some other components, and so on. And when requesting a new plan, the system will make a trade-off between this desiderata of the user and the learned user preferences and the feasibility constraints. So we made doesn't work anymore. Okay, we made some experiments with users, and as I said, we implemented this as a web application. So the user would go to the website, see some video tutorial, and then interact with the system. Eventually, they will either choose a plan or exit without choosing, and then they will be asked to fill in a questionnaire. So what we wanted to test here is our ability of our system to deal with the quality of our system against pool-based alternatives that are typical of telco companies' offers nowadays. So our system is the CC system, which has both a constructive interface, which allows for the user for modifications, and a constructive algorithm, which takes advantage of the full combinatorial space of solutions. And we compared this against pool-based alternatives, where a pool-based algorithm is the same algorithm, but is allowed only to pick recommendations from a fixed pool that we gathered together with a domain expert. And the pool interface is the same interface, but the user cannot ask for modifications and can see only the plans in the pool. And of course, the user were assigned randomly to any of these systems as they got to the website. So here's the results that we got. These are quantitative measures of usage from the users. We can see here that using CC, so our algorithm held 29% more satisfactory interaction. That means 29% more users were satisfied at the end, so they chose a plan at the end. And they did so with 3.5 iterations less than the other systems, and 2.9 minutes less than the other systems. And here are some results from the final questionnaires. So we asked a bunch of questions. These are the most interesting ones. So we can see here that the PC system was the least pleasant to interact with, both in terms of pleasantness and tiringness. We think that this is the case because of the mismatch between the interface and the algorithm. Then we saw that many users thought that with the CC system they got increasingly interesting recommendations, and surprisingly we got no statistically significant difference in satisfaction degree. And we interpret this fact as basically if you chose a plan in the end, you're going to like it no matter how you end up with that plan. And this was quite unexpected and interesting. So in conclusion, we developed this smart plan system, which is a constructive recommendation system that is able to elicit user preferences over a large combinatorial space of choices. And we made experiments, and it turns out that using a constructive algorithm is good for to have more satisfied users in less time. Thank you. Any question?
Hi, Keith Williams, Red Ventures. It seems like you care only about the user's preferences here, but if you're sort of selling these telco bundles, you might want to take into account the seller and what they want to do. So you want to try to upsell, do these types of things. Did you consider that at all in your study?
So we took very much the view of the user here, but we can easily embed companies' constraints inside the model that we use in order to generate new plans. For instance, in terms of pricing and other strategies, and they can easily be incorporated in the system.
Thank you.
Yeah. Any other questions? Yeah.
So, Rafael from Accenture. It appears that you modeled the rules in a way that whatever you do has an impact in the price in a way that you don't have like sub-bundles, such as maybe if you add Spotify, you also get Netflix. So the customer has an approximation of what happens to the price at each choice she makes, right? Did you consider that sometimes bundles have more complex rules and that would be hard for the customer to interpret the effect of the choices that he's making because there are such complex rules beneath? Maybe you use very simple rules that would be useful for the customer to interpret, but reality is a bit different. Did you consider this?
Well, we sort of modeled something like that. So basically what we did, in this interface, we had the base price of each component, and then the final price was not only the sum of the basic prices, but also some discount based on the number of services you were using and it was in the plan and other factors as well. Basically, you can put this type of constraints in the model, and then depending on the interface you use, you can inform the user whether you want to or not. I don't know. Does it answer the question?
Sure, yeah, thanks.
Okay. Okay.
Okay, more questions? If not, we can thank the speaker.
Okay.